this is Gowzahr, the self-proclaimed physics detective. Today I'm taking a closer look at Star Trek Into Darkness. Be advised there may be some spoilers to follow. In the film, Admiral Marcus commissions the USS Vengeance in secret and uses it to hunt down Captain Kirk and the Enterprise crew after they fail to follow his orders to execute Khan without a trial. Kirk attempts to warp back to Earth, but the Vengeance catches up to them and disables the ship, stranding there somewhere near the Earth's moon. Anyway, the confrontation between the Vengeance and the Enterprise concludes with the Vengeance being severely crippled, and the Enterprise losing power and falling towards Earth. The question that I seek to address today is whether or not the Enterprise could have made it to the Earth as quickly as it seems to in the film. In order to answer this question, let's first talk about how gravity works. According to Isaac Newton's theory of universal gravitation, every object in the universe is attracted to every other object in the universe by gravity. The strength of the attraction between any two objects is dependent on two factors. First, the mass of the two objects in question, and second, the distance that separates them. Mathematically, this relationship can be expressed as, where F is the force of gravity pulling the two objects together, G is a number that represents the overall strength of gravity. M1 and M2 are the masses of the two objects, and R is a distance from the center of one of the objects to the other. For this problem, the two masses that we're dealing with are the Earth and the Enterprise. Thankfully, we don't actually need to know how much mass the Enterprise has in order to figure out how long it will take for it to fall to the Earth. To understand why, consider a drag race between a scooter and a truck. As drag racing is all about acceleration, one of the biggest factors in determining which will win is the size of their respective engine. However, we can't just directly compare the size of their engines. The truck, being bigger, will naturally require a larger engine to achieve the same acceleration as the scooter. So a better predictor of which will win is how large the engine is compared to the vehicle itself. What this means is that it's possible for the two to have the same relative size in their engines, which would give them the same acceleration, resulting in a tie. So let's compare this race to a different race, one involving a hammer and a feather falling towards the moon. The scooter and the truck are comparable to the feather and the hammer, respectively, while the engines are comparable to the gravitational pulls that each experiences. Just as the truck needs more force to accelerate than does the scooter, so too does the hammer need a stronger gravitational pull than does the feather. But, as we saw earlier, the gravitational pull between two objects depends on the mass of the two objects. So yes, the hammer does need a stronger pull to accelerate at the same rate as the feather, but because it has more mass, it feels the necessarily higher gravitational pull, and the two will accelerate at the same rate in the vacuum of space, where there is no air resistance to slow down the feather or hammer. As a side note, the reason that we're talking about a race between a hammer and a feather falling towards the moon is that during the Apollo 15 moonwalk, Commander David Scott dropped a hammer and a feather during a live TV broadcast, and they indeed fell to the moon at the same rate. Anyway, while we don't need to know how much mass the Enterprise has, we do need to know where it started. Thankfully, Sulu says, when they drop out of warp, that the ship is 237,000 kilometers from Earth. With that in mind, we find that it would take almost 2.5 days for the Enterprise to reach Earth, being moved by the Earth's gravity alone. So it's clear that the ship fell much faster than it should have. Now you may have noticed that I said it would take 2.5 days if moved by the Earth alone. So if you have a theory on what else may have given the Enterprise a push or pull towards Earth, let me know in the comments below. If you're interested and feeling daring, then you can check out this other video that I made where I detail the methods used to calculate the time it would take to fall to Earth. If you like this video, then don't forget to hit the thumbs up below. Also, if you want to see more videos like this, then subscribe to my channel. You can also check in on my future projects by following me on Facebook and Twitter. Well, once again, this is Gowzahr, the self-proclaimed physics detective, signing off.